Hi there, this is Susan Norrell, and we are going to be talking about prime factorization. This is where we are trying to break down a number to prime numbers. So let me pull out a pen here, and we will talk about some of the prime numbers that we can use. So when I think about prime numbers, I'm thinking about the numbers that the only numbers that will go into them would be 1 and itself. Numbers like 2, because 2 is only divisible by 1 and 2. Or 3, because the only numbers that can divide into 3 would be 1 and 3. 4 is not a prime number because 1, 4, and 2 can divide into the number 4. 5 is a prime number because it can only be divided by 1 and 5. 6 is not a prime number. Number 1 because it's an even number. So any even number can be divided by 2. So 4 can also be divided by 2. But 6 can also be divided by 3. So any multiple of 3 is also going to be not a prime number. So we've got 7 can be a prime number. 8 is even, therefore it won't. But 9 is divisible by 3, so it's not a prime number. 10 is even. 11 is a prime number. 12 is even. 13 is a prime number. 14 is even. 15 is not a prime number because it is divisible by 5. So any number that ends in a 0 or a 5 can not only be divisible by, if it's 0, it's an even number, but it can also be divisible by 5. So 16 is even, 17 is a prime number, 18 is even, 19 is a prime number. So you kind of get the idea of some of our prime numbers that we're going to be looking for any of these numbers that will go into some of these products. So when we say that we are looking for write 42 as a product of prime factors. Factors means the two numbers that you multiply together, or the two or more numbers that you multiply together. So the factors are the numbers that are being multiplied, and the product is the answer to that multiplication. So the 42 would be the product, and the numbers that you're multiplying together would be the factors. So when you say write 42 as a product of prime factors, you're saying that you are multiplying these prime factors, these prime numbers here. These are the prime factors, the numbers you're multiplying together to give you a product, an answer of 42. So let's see here if I can get my eraser. There we go. And see if we can come in and come up with 42. Let's see. Right off the bat, we can see that 42 is an even number. So we know that it's going to be divisible by 2. So I always try to start with the smallest prime number. So let's see. 2 will go into 42. 2 will go into 4 2 times. 2 times 2 is 4. Bring down this 2 here. And 2 will go into 2 one time. 1 times 2 is 2, remainder of 0. So that's 2 times 21 is 42. So 2 times 21 is 42. Now we can break down the 21. So we want to find out what prime numbers will go into 21. Well, 21 is not even, so we won't try the 2. But how do we know if 3 will go into it? we have a little trick. If you add up the tens place and the ones place, and if those numbers add together to equal a number divisible by 3, then the value itself is also divisible by 3. So 21, look at this as 2 plus 1. 2 plus 1 is 3, and 3 is divisible by 3. Therefore, we know that 21 is divisible by 3. So, we know that 3 will go into 21. Question is how many times? I skip count. 3, 6, 9, 12, 15, 18, 21. So 3 times 7 is 21. Now 7, as we can see from our list, is a prime factor. So we have 2 times 3 times 7. So 42 is equal to 2 times 3 times 7. So 42 as a product of prime factors would be equal to 2 times 3 times 7. Okay, now we can try 63 over here. So I'll write 63. Now, I know that 63 is not even, so I won't even try the 2. But remember, we've got our little 3's trick. 6 plus 3 is 9, and 9 is divisible by 3. Therefore, I know that 63 is divisible by 3 as well. So the question is how many times? 3 will go into 63. 3 goes into 6 2 times. 2 times 3 is 6. Bring my 3 down. 3 will go into 3 1 time. 1 times 3 is 3. So 3 goes into 63 21 times. Okay, now we can break that 21 down again, and luckily we already know from our last problem that 21 can be broken down into 3 times 7. So we have 3 times 3 times 7. So 63 is 3 times 3 times 7. Now, for this next one, we have 45 as a product of prime factors. Now, remember I said anything that ended in 5 or 0 was divisible by 5. So we don't necessarily have to start with the smallest one. Let's start with the easiest one. 45, whoops. Lost my pen. 45, where's my pen? There we go. 45 is divisible by 5. How many times? Let's skip count. 5, 10, 15, 20, 25, 30, 35, 40, 45. 9 times. All right, so I didn't start with the smallest, but it was still efficient. Because now I know how to break down 9. It is 3 times 3. So my product of prime factors, if I list them from smallest to greatest, would be 3 times 3 times 5. So you can start with the easiest one and then still list them from smallest to largest. Okay, let's try the 78. Actually, why don't you pause the video and you try this one, and then press play to see if you got it right. Alright, if you hadn't yet, go ahead and try. I'll give you a hint. 78's an even number. So you should know that 78 is divided by 2. 2 will go into 78. $39 times. It's a pretty big number. I keep trying to change my colors. We know that if we add our 9s and our 10s and our 1s place, that we get 12, and 12 is divisible by 3. Therefore, we know 39 is divisible by 3, if you couldn't just tell by looking at it. So 3 will go into 39, 1 and 3. $13 times. And 13 was listed as one of our prime numbers. So our prime factorization for 78 is 2 times 3 times 13. $80 ends in 0. So we know it's going to be, first of all, divisible by 10. But 10 is not a prime number, so why don't we try 5? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So that's 16 times if you lost count. And I know that 16 is an even number, so it can be broken up into 2 times 8 if I count by 2's. And 8 can be broken up into 2 times 4. And 4 can be broken up into 2 times 2. So we have 5 times 2 times 2 times 2 times 2. This is a big one. 1, 2, 3, 4 2's. You might see this written as 2 to the 4th power times 5. Another way you might try this is going ahead and breaking it up into 10 times 8. Because you could always break 10 up into 2 times 5. And 8 into 2 times 4, and then 4 into 2 times 2. And then when you go back and search for your prime numbers, you can find 2 times 5 times 2 times 2 times 2. So you can see that you still have 1, 2, 3, 4 2's times 5. So there's always more than one way to do the problem. let's look at 99. Let's try 99 that way. That one's easy. 9 times 11. 11 is prime, so we just need to break up the 9 as in 3 times 3. So 3 times 3 times 11. Didn't quite box my answers here, did I? You could see this 2 different ways. All right, I will put these additional websites into the module here so that you can check them out. The second one, MathBits Notebook, is probably my favorite, but I also have Math is Fun and Khan Academy, so don't hesitate to check them out. Have a great evening, guys.